Hello everyone, welcome to Research-Based Learning Institute Teknologi Sumatera International Seminar.
First, what is Lorentz force? According to Britannica.com, the Lorentz force is the exerted on a charge vertically moving. Vertically moving with velocity v to an electric field E and magnetic field B. So, it can be concluded that the Lorentz force can arise with the condition that there is a conduction wire carrying current, and a current carrying conductor and the conductor being in a magnetic field.
The aim of our RBL group is to produce simple prototype of a moving charge and sharing carrying wires on a Lorentz force practicum tools as a physical learning medium. The research method used is the 4D model, namely define, design, develop, and disseminate. According to our analysis, the performance of the teaching aids and the validity of the practical tools are categorized as very feasible to use, while the response of TPB 9 students get a positive response, with a percent of 92%. And it can be concluded that the design of moving charge and current carrying wires in these practical tools is very innovative to be used as medium for learning basic physics for Institute Teknologi Sumatera students.
The secondly is tools and materials. The tools and materials used are power supply. The function of the power supply is to provide various AC and DC for transport equipment operation. Pliers. The function of the plier is a practical tool. Screwdriver. The function of the screwdriver is a practical tools. Sandpaper. The function of the sandpaper is to smooth the raw surface. Coil. The function of the coil is breaker electromagnetically and work when there is a short circuit electric current when there is a larger current due to a short circuit. This section will produce a flow or electromagnetic field from a coil that work to pull a magnetic lever. Magnet. The function of the magnet is to produce electric power which will be channeled through the coil.
How does this handy tool work? In this prototype, there is a flaming left-hand rule. This rule explains the movement of an electrically charged wire inside a magnet. The power supply will provide a DC current to the current carrying, where then the magnetic field will automatically provide a driving force on the wire coil. From the north to the south, also the coil will rotate according to the strength of the magnetic field.
Trial data. The experimental data in this practicum are electrical current 1 ampere, power supply voltage 6 volts, wire diameter 4 centimeters, and electrical resistance 6 ohms, and in variation with the number of turns, including 3 turns, 4 turns, and 5 turns. After that, the data obtained as the follow.
The last one is the advantage and disadvantage. Advantage 1. This practicum is very useful for our knowledge provision while in this study program, especially for those of us who are in engineering system and electrical engineering. Second, the model we made is very simple and can be varied again, whether it's never exceeded or just modify the existing one. The third, the prototype is very suitable to be presented in front of the class and is very easy for students to understand. Disadvantage. The first not suitable for high voltage experiment because the safety system is very weak. The second, the efficiency is very low because the prototype made is very simple.